So this video is going to jump between 5 different examples, and it's going to add a couple things that the other videos for perpendicular bisectors and angle bisectors did not. So this one, point E is on the perpendicular bisector DE. List all the congruent pairs of segments. So because it's on the perpendicular bisector, I know that it splits these two in half. And because point E is on the perpendicular bisector, I know that it makes these two congruent. And then this one is congruent to itself in the left triangle and right triangle because of reflexive property. So I know GF is 20. That makes both of these 10. I know EG is 13. That's 13. That's 13. And DE is 12. So DF is 10, EF 13. We already figured that out. So now go ahead and get this proof written down so that way we can get it started. Write out your given. Go ahead and number these angles 1 and 2. Because it's perpendicular bisector, I know I'm going to use those two angles. So we are essentially proving our statement that we just used in the previous one, that these two segments, EF and EG, are congruent because they touch a point on the perpendicular bisector. Our final step needs to show that our two hypotenuses here are congruent. So because it's a perpendicular bisector, I know angle 1 and angle 2 are right angles. And my reason, if perpendicular, then right angles. And since they're right angles, angle 1 is congruent to angle 2 because all right angles are congruent. So let's go ahead and mark those both as right angles. Perpendicular bisector, we're going to use the word bisector now. BD is congruent to DC. Let's mark that on our picture. That's these two here, and that's because it's a bisector. Definition of, let's do segment bisector. So definition of segment bisector, a perpendicular bisector splits a segment in half. Step 5, I know that the two triangles left side and right side are touching, so AD is congruent to AD, and that's a step we've been using a lot. That's reflexive. And number 6, let's mark that on our picture. Now I have side, angle, side. So I have two triangles congruent, so we're doing a lot of what we did in chapter 4. Triangle ABD is congruent to triangle. Remember, you have to go in a specific order. Because I went to B, I have to go to C first. And that reason is side, angle, side. And now because these triangles are congruent, I know that every part of these triangles are congruent, including AB and AC. CPCTC. All right, let's go on to another proof. AM is the angle bisector, and angle B is congruent to angle C. So AM is an angle bisector, and it's going to be this angle up here. So I'm going to number those 1 and 2. So step 2, angle 1 is congruent to angle 2. Let's mark that on the picture. Let's also mark our given on the picture, angle B and angle C. That is definition of angle bisector. And my step 3, I need a third thing in each triangle, and the two triangles are touching. So AM is congruent to itself. That's reflexive property. And now I have 3 things in each triangle. So triangle BAM is congruent to triangle CAM. because of two angles and a side. So now what I want to say, since it's an angle bisector, BM, or since triangles are congruent, since triangles are congruent, I know that every part is congruent, and that's because of CP, CT, C. So remember, because it's an angle bisector, you know everything is already congruent. So here's another property about angle bisectors. If a point is on the angle bisector of an angle, like point D right here, then it is equal distance from the sides of the angle. Equidistant. That means it's the same distance away. And we always do a distance as the closest, shortest line which forms a right angle. So from this point, we can always connect it with a right angle, and it is congruent. And the proof of this is because we can have right triangles and have an angle, and a reflexive side, kind of like what we just did in the proof. So let's use that to justify this reason. Let's solve for x. Angles bisected, meaning point D is the same distance from each side. So x plus 7 is equal to 3x plus 3. Subtract x from both sides, subtract 3 from both sides. X is 2.